Welcome to the lecture on catalytic cracking of heavy oil. In the earlier video, we had discussed about thermal cracking. Thermal cracking means cracking takes place at high temperature and pressure. In thermal cracking, the mechanism of thermal cracking is explained using free radical mechanism. And in this video, we will discuss about the catalytic cracking of heavy oil. So, catalytic cracking means cracking takes place using a catalyst. So, example, which is N-octane in presence of a catalyst, temperature and pressure. It will give rise to N-hexane and olefin. Here the olefin formed is ethylene. Here this N-hexane can be used as fuel, and ethylene is used in making plastics. So, coming to the types. Catalytic cracking is classified into two types. The first way of catalytic cracking is called as fixed bed catalytic cracking, and the second method is called moving bed catalytic cracking, or this can also be called as fluidized catalytic cracking. And now coming to the mechanism. Of catalytic cracking. Here, products are the result of both primary and secondary reactions. Primary reactions involve the initial carbon-carbon bond fission and the immediate neutralization of the carbonium ion. In the earlier video, while discussing the thermal cracking, I said the mechanism of thermal cracking is explained basing on free radical mechanism, and here the catalytic cracking takes place using carbonium ion mechanism. So here the products are the result of both primary and secondary reactions. So primary reactions means here in primary reaction, paraffin will be converted into again paraffin plus olefin. That means here the paraffin molecule will be cracked into paraffin and olefin. If the reactant is alkyl naphthalene, it will be cracked into naphthalene plus olefin. If it is alkyl aromatic compounds, they will be cracked into coke plus, or if it is aromatic compound, no, it will be cracked into aromatic compound plus olefin. So in this way the primary reactions takes place. Next, coming to the secondary reactions. Secondary reactions occurring after initial cracking steps are important in determining the final product of the composition. So, here if suppose the secondary reaction is due to hydrogen transfer, here in primary reaction, if we take alkyl naphthalene, so what are the products formed in the primary reaction? Naphthalene plus olefin. So these primary products will now undergo the secondary reactions forming aromatic compound plus paraffin. So these are the final products formed. So this formation of aromatic and paraffin compounds is taking place due to hydrogen transfer. If suppose it is aromatic coke precursor, plus olefin, then here the products formed are coke and paraffin. And if suppose the product is formed through isomerization, here olefin, so it will isomerizes and forms isoolefin. The secondary reaction may also takes place through alkyl group transfer. For example, if we take xylene plus benzene, so here this one what I am saying, xylene, this is benzene. Due to transfer of alkyl group, here we will be getting toluene. The secondary reaction may also takes place through condensation reactions. Here if you take vinyl benzene plus olefin, so this will condense and gives naphthalene products. The secondary reaction may also takes place through disproportionation of low molecular weight olefins. disproportionation of low molecular weight olefins. For example, if we take 1 butene, so this will be forming propene and one pentene. So in this way, secondary reactions are important in determining the final product composition. So coming to the detailed scheme of catalytic cracking of paraffins. So the feed paraffins are propylene, butane, butene, gasoline. So all these are the primary products. So from these primary products we are getting the secondary products. So if we take gasoline, what are the possible secondary products? Isobutane, propane, ethylene, ethane, methane and coke. From butene we can get isobutane, methane and coke. And similarly from gasoline we can get the primary reaction directly N-butane, and from gasoline we can also get propylene. So now coming to the catalytic cracking. So as I already have said, catalytic cracking means cracking which takes place using a catalyst, temperature and pressure. Here the first method is fixed bed catalytic cracking. Here why we are calling this as fixed bed catalytic cracking means, here the catalyst, it will be adsorbed on artificial clay mixed with zirconium oxide, and this will be fixed in catalytic chamber. As this is fixed in the catalytic chamber, so here catalytic bed we are saying, no? So in this catalytic bed, what will be fixed here means the catalyst will be adsorbed on the artificial clay which is mixed with zirconium oxide, and that will be fixed here. So that's why we call this method as fixed bed catalytic cracking. Here the heavy oil which is obtained by fractional distillation of petroleum, that will be preheated to a temperature of 425 to 450 degrees centigrade under a pressure of 1.5 kg per centimeter square. Now these vapors will be passed into this catalytic bed. So during this preheating process only, nearly 40% of the charge will be converted to gasoline. Next, these vapors will be passed into the catalytic chamber. Here in catalytic chamber, cracking process takes place. Now the cracked products will be passed into the fractionating column. So here in fractionating column, different fractions will be separated depending on the difference in their boiling points, and the gasoline vapors will be cooled by passing into a condenser. After that, gasoline will be stabilized by stabilization process. We will discuss in detail about the stabilization process in the next coming videos. Next one is moving bed catalytic cracking. Here, catalyst will be made into fine powder. This fine powder will be passed into catalytic chamber. In this catalytic chamber, the particles are free to move like a fluid. So that's why this can also be called as fluidized catalytic cracking or moving bed catalytic cracking. Here, the heavy oil vapors will be passed into the catalytic chamber, which consists of the catalyst which is made into fine powder. Here, the cracking process takes place. And the cracked products will be passed into the fractionating column. So depending on the difference in the boiling points, different fractions will be separated here. The gasoline vapors will be passed into a condenser which cools the vapors, and the gasoline obtained is stabilized by using a stabilizer. After some time, here what happens means the catalyst particles, the powdered fine particles of the catalyst will settle down at the bottom due to the deposition of carbon on the surface of the catalyst. Now these particles will be removed, and from these particles carbon will be removed by burning. Next, again these particles will be passed into the catalytic chamber for carrying out the moving bed catalytic process again. Whereas in the case of fixed bed catalytic cracking, here the catalyst has to be regenerated after 8 to 10 hours. Here also nearly 2 to 4% of carbon will be deposited on the catalyst. So this will also be removed by burning the carbon. Now coming to the advantages of catalytic cracking over thermal cracking. The first advantage is high yield. When compared to thermal cracking, more yield will be obtained using catalytic cracking, and better quality of the gasoline, and which has better knocking properties also. No external fuel is necessary for cracking. A much low pressure of 1 to 5 kg per centimeter square is needed. Process of cracking can be controlled. Here pressure of 1.5 kg per centimeter square is needed. Percentage of gum forming compounds is very low, and production cost is also low. Thank you.